So I realized that we, oh, that's the wrong one. That I had skipped one. Right, so we're doing inverses, composition and inverse before we do the inverse one. So the inverse one was when I was supposed to show you how to find inverses, which I did on the fly last time, but it's actually laid out nicely in this handout that you have now. So we're going to go through the inverses, finding inverses of linear functions, which again I showed you last class, but we'll go through it in a little more detail with some more practice now. And then we'll finish up the functions with composition and inverse. And then lastly today we'll do the absolute value graph translations. So once we finish up those, that's kind of everything for units 1 through 3. And then on Friday we'll do review for the exam all day Friday. And then I'll let you guys go home and work on the practice exam if you like, and then Monday we'll spend the first half of it sort of just doing some review of anything if people have questions about the practice one. But the one I handed out to you guys, that one is literally the exam. I mean, not literally the exam. It's the same problems as the exam. Just it'll be slightly different situations, it'll be slightly different numbers, but same. Those are the types of problems you're going to have. Right? It matches up really, really well. It's just, I'll give you a different version of it, right? So today you have in class the graphs of inverses and one-to-one functions. So if you guys want to get those out and pass those in, that's great. If you don't have it done yet, you can turn it in after lunch, so that's totally fine as well. I'll just leave them, I'll have them, you can just, I'll put them right up here, so you can just turn them in there. And then you have My Open Math Unit 3, Linear Equation Review, due tonight. Friday you'll have the in-class linear models homework that we handed out last class. Right? Except remember I crossed out, like pretty much every even problem is crossed out. So that's due on Friday. And then also you have your My Open Math of linear models due on Friday as well. Sunday you'll have you'll have My Open Math of inverses and linear functions, right, which we kind of touched on last class, and we're going to go over a lot more today. And really, what this is the homework that was due last time had 8 of these inverse problems in it, and you guys weren't ready for those there. I put them in the wrong spot, so I shifted them down to here. So this is just the continuation of that Chapter 2, or Unit 2 homework that had these problems in it. So it's just 8 problems, working on inverses again, finding inverses. The exam is Monday. I think we'll go with Monday because that will actually hopefully give us, an opportunity to give you guys a day off in the future possibly. So we're going to go Monday, October 18th, and there we go. Questions? No questions? Okay. All right, so let's go ahead and take a look at the inverses of linear functions. So grab out this handout I just gave you guys. Okay. So first, do you folks remember what the inverse of a function is? What special property does a function have to have in order to have an inverse that's also a function? Do you guys remember that? So first of all, how do we determine if a function is so a function is a function if every x value only has one y value. Everybody remember that part? Yes? Yeah. So in other words, every x can only go to one y. It can't go to 2 possible y's, right? It can't have 2 possible answers. Here I'll give you something concrete. And so 1 only goes to 3. 1 can't go to 3 or to 4. That's not a function. Yeah, everybody remember that part? But the inverse, we want its inverse to also be a function. So, do you guys remember what we called that?
1-to-1.
1 to 1. Everyone remember that one? So every x only has one y, every y only has one x. They're kind of paired up, right? They can't. They're kind of monogamous. You think of it that way, right? Okay, great. So we call that 1 to 1. Right. So every x and y only have one kind of partner, I guess you can say. So they each only occur once. Let me give him a handout. Okay. There's also a special notation for the inverse of a function. Do you guys remember what that is?
Oh, yeah.
Yeah, so why don't you tell you guys what? Why don't you guys take a couple, like a minute, and discuss with your neighbors 2 and 3, and see if you can come up with it. So neighbor up, flip around, neighbor up, and then, yep. Or you can shoot across this way too. Or turn around, he's there now.
Superscript, negative superscript or something?
Yeah,
What is it, F?
like,
Negative superscript or
it can be like any number. Oh, for fx, it'd be,
What's the notation for an inverse of a function?
it's -1.
Yeah, okay. It's not, okay.
I don't think it's subscript.
No, superscript,
Jenna, what do you think it is?
yeah.
Did you talk to your neighbors about it?
How does it work?
Alex, you got it? You guys sorted it out?
Oh, the X
Yeah,
is
we're
the
talking
Y,
about
reverse, right? The X goes to Y, position, Y goes to the X position?
Yeah.
Property has to be 1 to 1. Inverse is.
Okay, so Ryan, what's the notation for the inverse of the function?
Is it f of -1?
F of -1. Like kind of F raised, the function raised to the -1 power. So remember, whenever, that means kind of the opposite, right? Because we've seen, whenever you have an inverse, whenever you have an exponent to a negative exponent, it kind of undoes it, right? Because normally, like x squared would mean you multiply by x twice, but x to the -2 means you divide by x twice. You kind of do the opposite. So f to the inverse means you sort of do the opposite of it. You undo it, because an inverse undoes a function. So for example, the inverse of adding 3 would be what?
-3.
Subtracting 3, yep, minusing 3. The inverse of dividing by 3 would be multiplying by 3. Right, those are inverses of each other, thank you. Maybe that's not very clear. The F inverse. Okay, how does the inverse work? If we know that the input of a function is 5, then the output will be 8. Right? Input is 5, output is 8. Then what about the inverse?
5.
Right? An input inverse, an input of 8 will have an output of 5. In other words, what happens with the x and the y?
It's what?
They swap.
Yeah, they swap places. Right? And I really want you guys to, I'm really encouraging you guys to use the word swap, because swap, you get used to them switching places, as opposed to like, sometimes people will use some other word, I can't remember what it is, but they start thinking that means they change signs, and that's not true. They swap places.
So no flip or no switch.
I'm sorry?
No flipping, no switch.
Yeah, exactly. The flip of the switch is what people start thinking. They start changing, because you all hear like switch signs. You guys have heard that a lot when you're younger, so they think it goes to signs, and it has nothing to do with the signs. If it's positive, it stays positive. If it's negative, it stays negative. They just swap places. Okay. All right. So, in these exercises below, complete a table of values for the linear function given, and then use that table to write to write the inverse numbers. So now let's just swap their spots. So I'll do the first one with you guys. Let's pick some numbers for x. Let's go 0, 1, 2, 3. How does it sound? And over here, let's go 0, 2, 4, 6. And the first one, if I put in 0 for 3, again, you're basically doing this. F of whatever, giant parentheses, equals 3 times giant parentheses, whatever x is, minus 1. And you're just going to pop each of these in for x at a time and see what you get. All right, so if I put 0 in here and 0 in there, what do I get? 3 times 0 is 0, minus 1,
Negative 1.
negative 1. I put 1 in there. Round it out, what do you get? So, tell you what. Oh, and then, after you finish, okay, so if I put 1 in there, what do I get? 3 times 1 is 3, minus 1 is 2. Great. And then after you finish these, go ahead and just swap the spots. So 0, 1 becomes, or 0, negative 1 becomes negative 1, 0. They swap places. Okay, so take 2 minutes with your neighbors and do 1 and 2, and then we'll come back. At home, pause this until you finish and then start again. Let's take a look. All right, so here, if I put 2 in for 3, into here 2 times 3, so remember we do multiplication first, that's 6 minus 1 is 5. If I put 3 in here, 3 times 3 is 9, minus 1 is 8. And then the inverse is just the x and y swapping places. So 1, 2 becomes 2, 1, 2, 5 becomes 5, 2, 3, 8 becomes 8, 3. But here, half of 0 is 0, plus 2 is 2. Half of 2 is 1, plus 2 is 3. Half of 4 is 2, plus 2 is 4. Half of 6 is 3, plus 2 is 5. And then, again, with the inverse, the x and the y swap. 0, 2 becomes 2, 0. 2, 3 becomes 3, 2. 4, 4 goes to 4, 4. 6, 5 becomes 5, 6. Okay, good? Great. All right, we're just giving you guys some process doing things. And remember what happens graphically? They get reflected across this line, this diagonal line, y equals x. Right? Remember we saw that before. We did some of that reflection stuff, and we saw that a point that was here ends up over here. Because, for example, this guy, negative 1, 4 becomes 4, negative 1. Kind of down here, right? So it works that way. They get swapped. When the x and y swap, then they swap across this line y equals x. Because that's kind of the reflection. Oh, I guess I sort of answered that already. Right, so when you graph the inverse of a function, I've just kind of told you, so you guys write down in words what I just described to you. It's reflected across what line? Right, so illustrate, so draw something like what I drew and make that work. You can draw something else if you want. You can draw anything you want for the first one and anything you want for the second one. Just that's which means that if I were to if I tilt my head this way, those should be mirror images of each other. If I fold it along this line, they would lie right on top of each other.
So are the little
Mhm.
ones, though, is
What?
it like happy faces on
Yeah.
there? Is that indicating that that dot went to the next dot, or I thought
Yes.
it went across the line?
This dot went to that dot.
Across the line, okay, so it's not
Yeah, it's
indicating,
reflected across that line.
okay, it's not indicating then that it went just to the top, the two top dots, because it looks like that happy face is indicating.
This guy went here. They're mirror
Okay.
images of each other.
Well, that's what I thought, yeah, but.
Yeah.
But-
So that means this one went over there, that one went over there, this one, they would go like
Okay.
that. Maybe my drawing's not perfect, but
Oh, yeah, it was just,
you have to kind of roll with that part. But that's what I mean, it's like a happy face here will go across there.
okay, I got you.
Yeah. And I think if you want me to draw my chin better, I can draw my chin better. Oops. Oh, my other eye should be further over, that's why. I'll draw it better. So he's there, he's at like 3.5, -1, 3.5, -1. He's at 1, comma, -1, 2, 2, -1, and goes out to 2. How's that? A little more accurate, I don't know, it's kind of hard to. Okay. Bless you. All right, so we can use reflection across the line y equals x to sketch the inverse of a linear function. So we're going to do just that. We're going to grab these points here, and we're going to reflect them. So, and we'll do the same thing with this one. Grab these points here, and reflect them across the x-axis, well, just swap the points. So this one here is -2 and then up 5. What's this point down here? How do I get there? Start from the origin, you go right 3, so it's 3, comma,
5. Three
yep,
negative
down
5.
5, yep. So that's 3, comma, -5. So then what is their inverse? -2, 5 becomes, -2, 5 becomes what, guys, folks?
5, -2.
5, -2. -3, 3, -5 becomes what? Anyone?
-5, 3.
-5, 3, thank you. So then if you draw a line between them, oh, look at that, it goes right through. So where it crosses the line, they should both meet. And oh, if you do it, here's the thing too. So did everyone do those points? If you draw a really heavy pencil across this line here, we'll try it. I'll show you what I mean. Take a pencil and draw a super heavy line across that spot. I have a pencil. There we go. So like a super heavy line with your lead. Like right on the actual line. So right on this line here, draw a super, super, super heavy with your pencil, and draw it like that, super heavy,
Oh, on the
with your,
original?
on the original one with your pencil. And then, So I've drawn a super, super heavy line right across there on the original one. Can everyone see that? So just draw a super heavy line right across there with a pencil, and then fold it right along that line, the y equals x line, along that dotted line. And like press the paper down. Maybe scratch along there. You'll see. I got a little imprint of the other one, a vague imprint of the other one. Right. So it's kind of cool. You can get a little big imprint of the other line. It's not perfect, but you can kind of see. See how I got my little.
Oh, yeah, that matches this
Yeah.
matches this.
Right, so it's kind of,
Really,
you gotta really make that heavy, yeah. Yeah, and then you can kind of just kind of sketch it through. All right. But yeah, so, right, so now do you believe me, right? You probably believe me anyways, but you know, you can see it's reflected across the two. You draw a line across there and you can get it to match up. Okay, so you guys do the same thing with number 2. And actually, let me give you another one to work on. So sketch a graph of linear function. So here, I want you to do the same thing, only sketch it yourself. All right, so let me give you some hints for drawing these guys. So first, let's just, for temporarily, let's just ignore what that is, what these are. Someone give me a number. 5, okay. I'm going to do plus 5. So let's do 2x plus 5. How's that sound? And then you don't draw this on yours. Not yours, this is just mine. I just want to show you some stuff about graphing. I'll do minus 3 minus what? Someone else give me a number. Any number. Give me a number.
7.
Minus 7. Okay, great. So here, I can graph this really fast. Plus 5 means boom, I'm going to start at 5. That's my x-axis. My slope is 2x. Oh, I should have done this the other way. Oh, I'm sorry. Thank you. And I'm going to do, I'll do minus 2 here, and I'll do plus 3 there. Okay. So I'm going to start at 5. There's my 5. And then my slope is negative 2. That means I go over, my run is 1, I drop down 2. Run is 1, I drop down 2. So boom. Then you have that. You can kind of graph that easily from there. You guys kind of see what I'm saying? Here,
Always 1?
well, I could run, my slope is negative 2. That means for every 1 I go this way, I go down 2.
Oh, it's always 1.
Well, I could pick a different one. I could say, if I run 2, then I drop down 4. But I mean, it's easier. Negative 2 over 1 is the easiest. Because what fraction is negative 2? Negative 2 over what?
Oh, negative 2 over 1.
Yeah, over 1. So that means my run is going to be 1. My rise is going to be negative 2. Rise over run. So my rise will be negative 2. My run will be 1. Does that sort of make sense? That's the easiest one to grab because I already have negative 2. Let's make it negative 2 over 1.
So you can always use that.
Yeah. So that will give you all those points. And then over here, negative 7 means boom, I start at negative 7. And then my slope is 3 over 1. So I'll rise 3, 1, 2, 3, run 1. Rise over run, rise 3, run 1. Rise 3, run 1. So then I've got my second line. Go right through there, like that. Everybody on board? So that's the easy way of graphing these for that function. This is your y-intercept. It tells you where to start. Let me say that again. It's that plus at the end. The y, remember we have mx plus b? Everybody on board with mx plus b? Let's talk about this for a second. Y equals mx plus b. B, this is your y-intercept. Also known as your initial amount or your starting amount. It means when x is 0, where are you? So that's your, right, that's this guy here. That's this guy here. Start at -7, start at +5. That tells you where along the x-axis you're going to start. And then the slope, this is your rate of change, right? Or my rise over run. So just make all of these, -2 would be -2/1. 3 becomes 3/1. So it means that I'm going to -2, 1. Everybody kind of following where we're going here? So this would be -2. I drop -2, I run 1. Here I'm going to rise 3, 1, 2, 3, run 1. Good? Keep doing that. Right? Rise 3, run 1. So that's sort of the shortcut way, that's the easy way of graphing, right? Why do things the hard way? You have a function, you've got a graph, that's how I do it. Okay, so first you need to graph your first linear function, and then you've got to sketch in your dotted line. Use a dotted line, please. Sketch in your x equals y line, and then you can do the reflection. So the first one, we've sketched them in for you, right? This dotted line, you've got to sketch it in yourself on the bottom too. All right, so let's go ahead and we'll take a 5-minute time to work on those ones, and then we'll come back. So at home, go ahead and pause the video now, and then start back when you're finished. To help, here's the thing. Remember this y-axis, this y-intercept, you always start on the y-axis. So that -7 means it's on the y-axis, it's actually on this line. So you go to -7, that's where you start. +5, on the y-axis, on this line, that's where you start. Then from that point, you look and see what your rise or run is. So if there's no number in front of x, there's an invisible 1 in front of x. So 1 would mean that you would, you would start, here I'm starting at -3, and it's invisible 1 in front of x, so it's really 1/1. So I'm going to rise 1, run 1. Rise 1, run 1. So make dots here, and then draw your line. Don't forget to draw your dotted line, everybody. Right? And then reflect it. So after you've drawn in the function and you've drawn in your dotted line, then don't forget to reflect it across the other line. So I think so far, everybody has gotten everybody has gotten as far as that. Is that right? At least. Now you need to reflect it. So remember, it goes across here. So here, if this one. Oh, this one's easy. I picked this one and I picked that one because they're right on the grid points. They're easy ones. They're easy ones to get. So this is 3, 0 should go to right? And just figure out what they are. Swap your points. So 0, -3. Should go to -3, 0, 0, 3. And once you get 2 points, you can draw your line for the other one. Just get a piece of paper or get a something that's going to draw through there. And then do the same thing for the other one. Again, pause it if you can't at home and do the other problem. Super common problem people are having is okay, I'm starting at 3, so I'm going to put my spot here at 3.
2, 1, and then.
But I think people are getting messed up, realizing this is -1, but it's really -1 over +1.
That's why I thought I messed up, because it was on the same line
Right, 'cause it's
again.
-1
So you
over
don't even do
+1, which
anything,
means
you
that
label it again, right?
I'll
Except for
go
this
down
one.
1, but I still go to the
Because
right
these two are just
1.
flipped, and they're gonna be on the same thing.
Down 1 to the right 1. And then don't forget to put in your dotted line.
Well, you did a second one, she's
And reflect.
homework, 'cause I could not, I was up till 2 o'clock in the morning, and I could not figure what the